After the voltage-controlled current source, the current control voltage source is going to seem pretty easy. If you look at this circuit, it's very similar actually to the standard inverting amplifier, except that we do not have an input resistor. Instead of driving the input with a voltage through a resistor, we simply connect a current to that. No resistor. We know what the current is. It's I sub n. All of that current has to go through the feedback resistor, therefore we know what the voltage must be across the feedback resistor, thus the output voltage has to be I sub n times R sub f, except it's got to be minus, so it's going to be minus I sub n R sub f. Note that that is completely independent of whatever that load is that's connected to the output terminal. V sub L is simply minus IN times R sub F. So that was pretty easy. Now let's look at the current-controlled current source, which is a little bit harder. Notice that the load in this circuit is a floating load. It's not grounded. Later in the course we will probably take a look at a circuit which will allow us to implement a grounded load current-controlled current source, but that will just have to wait. Alright, let's do a quick analysis of this. We've got some current I sub n, which we claim is going to control the current through the load, I sub L. All of the current I sub n must go up through R2 since it cannot enter the operational amplifier. That means the voltage across R2 is IN times R2 with the positive reference at the bottom. Since the inverting input is a virtual ground, then the voltage at the top of R2 relative to ground, which is also the voltage across R1 with the positive reference on the right, is minus IN R2. Alright, with that we can now determine what the current through R1 is. Now I'm going to define this current to the right so it actually enters our negative voltage reference. So you're going to have to work out the signs in Ohm's law there. But if we look at the current going from left to right through R1, it's simply going to be IN times R2 over R1. Alright, we know what the current through R1 is, we know what the current through R2 is. They both enter the node up there at the top. And so I sub L simply is the sum of those two currents, IN plus IN times R2 over R1. And if you simplify that just a little bit, you get that I sub L is equal to IN times 1 plus R2 over R1, which is just a constant, assuming those resistors are fixed values. Now note there is one restriction in this circuit, which is that the factor by which you multiply IN to get IL has to be 1 or greater. You cannot have a current gain there of less than 1, but that's not a major problem at this point. We'll see how to get around that later on in the course. So there are our two current control sources, a current control voltage source, a current controlled current source. We will look at some more robust dependent source implementations later in the course.